Hi, welcome to How to Repair. In this video I'm going to be teaching you how to change a conventional thermostat in an oven, whether it's a single oven, a double oven or a freestanding oven. The principles are all the same. We're going to have a look how a thermostat works and the common faults on the thermostat. There are capillary thermostats which are designed to control the oven temperature, and on some ovens they're also designed to control the grill as well. On other ovens you would have this running the fan assisted oven or the conventional convecting oven, but the grill may be operated with a thermostat. This is an electronic thermostat, a non-capillary version, and this basically controls the grill by checking the resistance and turning the grill on and off to create the heat level that you require. On the conventional thermostat with a capillary tube, the end of the tube, which is in the oven, heats up. This expands a gas which goes through the pipe into the actual thermostat itself. Now inside here there is a set of points, and when it gets to a temperature, if we say 100 degrees, these points will be disengaged, cutting off the electricity supply to the element. When the oven cools down below 100 degrees, this then will activate the points, in other words opening the circuit at the bottom, and this will allow electricity to flow through to the element. We'll have a look at 4 different types of oven and the different systems that are in place. On more modern cookers now, we are using control boards, which in my honest opinion is going over the top with the design, and if something goes wrong it becomes a very expensive item to replace. This is controlled via an NTC sensor, which then basically tells the computer board a certain resistance at a certain temperature, and then activates a relay to allow electricity to go through to the element in the cooker. Okay, let me talk you through one of the most basic ovens on the market. This is a convection oven. It has a selector switch, a thermostat, a cooling fan, a single base element and a dual element for the grill. Let me explain how it works. Function 1, for example, maybe just turn the light on. Function 2 will be using the outer part of the grill element in conjunction with the base element, therefore creating a convection oven. This is controlled by the thermostat. If the thermostat was failing, you'd most probably find that your food is constantly burning, but this may also be happening because the base element may have gone faulty. Therefore you're only heating the food from the top and you think it's overheating. So section 3 on the controller would be maybe just the base element. This would be used for just creating heat to flow up in the oven for different type of cooking. You may be doing a casserole or something like that where that would be very useful. Again, this is controlled by the thermostat. Number 4 would be the grill, and on this model we have 2 settings for the grill. We have inner grill or complete grill. This is again controlled by this thermostat. So it's a very basic oven. Just some other pointers for you. We have a thermostat here and a thermostat here. One is a cut, I think both of these are actually, one is a cycling thermostat and the other one is a cutout thermostat. One is designed to control the fan, so when the oven gets up to 100 odd degrees the fan will automatically come on to keep all the electrics and everything at a reasonable temperature. And the other one, I believe, is a cutout thermostat. That means if the oven or the temperature outside the oven ever exceeded, say, 240, 250 degrees, this may go open circuit and stop the cooker from working. Basic, simple, very reliable, easy to maintain, should last you a lifetime if you know what you're doing and you're able to get the parts. Again, I've got videos at the website showing you how to replace elements, how to test elements. I've got videos on the fans, very good video on how selector switches work, and this at later on in the video I'll show you the inside of one of these thermostats so you get an understanding of exactly how they work. Next we'll deal with a fan assisted oven. Okay, let's talk about a fan oven, a little bit more advanced. Still we have a selector switch which allows us to control what setting that we want. We also have a thermostat. On this model we have a timer which has a relay that also is in between the circuits, so if you want to cook on auto functions, this relay is what allows it to start at a certain time and stop at a certain time. The elements, exactly the same as the conventional convection oven, but with an additional element called a fan oven element. Again, you can see all about fan oven elements at our website, but we have a base element, a fan oven element, we have a fan, which is the circulation fan for in the oven, and we have a dual grill as well. We have a cooling fan at the top, which is a different type. This one actually spins round rather than throwing the air over on that one. And basically the function settings on this. Function setting 1, again, same as before, light. Function setting 2 is the fan oven. Now the fan oven works in a different process to the conventional convection oven. You have an element at the back with a fan motor that is designed to circulate the air around the oven. This is controlled by the thermostat. Now the thermostat only controls the element, it does not control the fan motor. As soon as you turn the oven on, the motor will always be running. It is very important that the fan motor is working correctly, because if it isn't working correctly you can end up with hot spots occurring on the fan oven element because it's not getting air circulating around it. Again, same type of fault. If the thermostat was faulty, this would cause you basically either the element not to come on, or it will be too high a temperature and it could be burning the food. The next setting is the fan motor using the grill. The fan element is now not used, the grill is used with the fan oven. It might be for browning stuff, for Sunday roast or something like that. Again, the thermostat now, because you've changed the selector, is now controlling the grill element, not the fan oven element. The next one is just the grill. Now the thermostat now controls the temperature around the grill area, and you would turn it to a high setting if you wanted to grill on full power. You would turn it to the middle section. Again, if your grill is overheating and burning and you've got no control of a grill, this could be a thermostat fault. The next one is inner part of the grill only, and the next one is exactly the same as the convection oven. This uses base element and half of the grill element, and again, because the selector has now selected those two circuits, the thermostat controls this. Same faults as before can happen if your thermostat is not working correctly. And the last one is the base element only, as I said, for casseroles, and because we've now selected the selector to base element only, the thermostat controls the temperature. The one thing I forgot to mention on the earlier one, it is very, very important, and I do not understand why the manufacturers do not put this in their manuals on all cookers. It is very important that you never turn the selector from the off position to a setting with the thermostat on, because if you do this you're actually going to be causing a spark as you select the selector going round on the points on the selector. You can see exactly what I mean with this in our video on selector switches. So the procedure you should always use is turn the oven to the off position with 0 temperature, then select the setting that you want, so we say fan oven, then turn the temperature of the oven to the required temperature. When turning the oven off, do it exactly opposite. Turn the thermostat off first, then turn the selector to the off position. This will make the selectors last a long time, and this is why selector switches go wrong so often. Any other faults that can occur with this cooker, as I said, you've got a cutout thermostat. I don't believe you've got any on the back, but basic same protection systems in place with cutout thermostats, and thermostats automatically designed to turn the fan at the required time. The only additional circuits really is the timer. Next we'll look at a thermostat built into a selector switch on this other cooker, and we'll go through how this system works. Right, this oven has a selector with the thermostat built in to the back of the selector. This can be identified quite easily by just unclipping this. You can see the thermostat here, and it just slides into the back of the selector. This is a fan oven without a base element, so it is not a convection oven on any of the settings. The only settings we have for this oven is the grill and the fan oven. The grill is also controlled separately via electronic thermostat, which is, as I said earlier, works on the resistance basis. As the element gets hot, it produces a different resistance, and therefore the thermostat controls the temperature that way. This thermostat is only controlling the oven. So we have two thermostats built into this. Same again, timer. No base element, as I said. We've got a fan oven element and a grill element. And basically the only settings on this is when you first turn it on, the light and the fan will come on. Then you control the temperature and the element. That's all controlled via this thermostat. Then when you get to the grill setting, which is another click on the selector switch, it now disconnects this thermostat completely and is now sending power through to the grill via the electronic thermostat, and this is what controls. So if your oven is heating correctly and working correctly, but you have no control over the grill, then this may be the problem. This is an electronic simmerstat, they call them in the trade, or thermostat, but you've got electrical ones and ones with capillary tube. Exactly the same as the other two ovens. So there's nothing complicated. All three of these ovens are good, reliable, and easily serviceable. The next one we'll look at is the more modern electronic one, which I do not rate because they're highly expensive to repair. These electronic versions, which are controlled with circuit boards, have a tendency to fail, like all ovens. But when this fails, you have to replace the whole circuit board, and this will cost in excess on most electric cookers £80 to £150 depending on the make. Very expensive thing when it goes wrong. Exactly the same principle. You have a number of elements. You've got a base element, a fan oven element, and a grill element. Dual grill. You have the cooling fan, the circulation fan motor. On this model you have a rotisserie bit, which is an optional extra, and we have an electronic interface for the door as well. There are lots of things that can go wrong with this, but the basic principle of how they work is we have a timer, and on this timer we have a NTC sensor which is built into the oven. This reads the temperature. As the temperature rises, the resistance will either rise and fall. I forget which way, but you can always see another video about how NTC sensors work at the website. And basically the functionality is controlled. Instead of having thermostats on the other cooker and selector switches, you have one circuit board that activates relays. And these relays basically act as we get to temperature. The relay will kick in to allow the element to be disconnected. When it drops below temperature, the relay then will activate, allowing electricity to flow through to the element and the element heat up. And you have lots of relays on this which control all different things. You've got one for the fan oven element, one for the base element, one for the grill element, other ones for fan motors, cooling fans. Highly complicated, Why manufacturers have to go down this road, I do not know. Circuit boards, yes, they can be cheaper, but they are unreliable. And you know, when you look at some cookers that have been about for 30-40 years and you look at this new technology, I disapprove of it. But that's only my point of view. A lot of manufacturers will disagree with what I say there, but the fact of the matter being is the conventional system has worked for many years and been very reliable and never had really many problems. These new systems, this circuit board, as I said, will cost in excess of £100. Basically, you're better off buying a new cooker rather than actually having a thermostat replaced or an element replaced or something else. Elements still go wrong in this cooker, but sometimes the circuit board go. And if the circuit board goes, it's bin material. Okay, now we've gone through all the different types of oven. I'm going to show you quickly how to change a thermostat, and then after this I'll show you how a thermostat works in detail. So to change a thermostat, first thing you need to do is disconnect the appliance from the electricity supply, and I always advise you to take the door off. It's usually easier. You can do it without. So on this oven there's a couple of clips that you push up. You lift the door carefully, give it a wriggle, and the door will come off. Next you need to remove all the shelving. And in the back here we have a capillary tube, which I'll show you in detail now. Okay, at the top here you can see the capillary tube, and this one is on a mounting plate. On other ovens it may be clipped onto the chassis. Sometimes there is a mounting plate on top of the grill element, but on this model what we'll have to do is just loosen off the two screws here. Now remember, because it's in an oven, sometimes these screws can be a little tight, and that's due to the expansion and contraction, plus moisture gets present, and sometimes it can corrode the screws. So we'll just undo this. And we'll just bring this down a little bit. Make sure it's nice and straight. Slide this off the holder. I just press down that a little bit to release it. So we'll leave that there. That's now ready to come out, and what we need to do is take the chassis of the appliance apart next. Every cooker comes apart differently, but basically what we're going to have to remove is the top half of the oven and also the back. So I'll quickly undo the screws. On this one is 2 screws for the front panel, and then 2 screws for the back. This then will come apart. Now we've got a couple of screws here. The back plate comes down. The top plate now can come off. And here is the capillary tube. It slots through the back of the cooker. Now I've already straightened it, so carefully pulling it through. Now we need to detach this from the wiring loom. So I'm just carefully going to thread this through underneath the cable ties so I don't have to cut them. Okay, on some cookers we have to take the facial panel off. On other cookers you'd be lucky and be able to pull the thermostat knob off and there'd be 2 screws exposed. But on this one we have to take the control panel off, but we're lucky that we don't have to remove these buttons. What you would normally do is, if the buttons are overlaid on the glass, you would use a very small screwdriver, put the screwdriver underneath and then just pop them out. They are a little bit fragile, so do be careful with them. So we'll take that off. Now we need to remove the facial panel, and that's 2 screws on either side. Some have 4, some have a clicking latch mechanism that the plate lifts slightly, but it does vary from cooker to cooker, so do take your time. Now the 2 screws are undone. Some of the manufacturers, especially on the Electrolux appliances, put a gasket seal at the top, so you'll need to use a Stanley knife, run that down the whole joint, and then the panel should come away. And these knobs, by the look of it, no, we need to cut the bottom as well. There's another gasket on the bottom. And you can see the silicone there, and that comes away. Now we've got the 2 screws which we can undo to remove the thermostat. And that thermostat is now loose. Now I would normally take a photograph of the wiring, but it's quite easy. This is numbered, so black goes on to number 2, orange goes on to number 1. That comes away, and we'll just slide the capillary tube down through underneath the clips, and there we go, we're ready to replace the thermostat. Okay, the new thermostat normally comes, be very careful if there's a cable tie on, just carefully snip it off. If you hold it like this and then slowly unravel it, making sure not to put any kink in it. And there we go. Now we can actually now slide this back down the same path as it came from, making sure to keep it away from all the electrics. I'll leave that there. I can now connect up the wiring, number 2. Make sure the thermostat's in the off position and the top of the shaft is normally facing upwards. We can put that back in there. Now we can put the 2 screws back in. Sometimes you're able to use universal thermostats on this. The temperature range on 90% of all cookers are the same. They basically run from 50 degrees upwards to about 260 degrees. Make sure the timer buttons sit in nicely. I'm not going to re-silicon on this one. I'm just going to put the 2 knobs on, just to make sure the glass doesn't fall off while I'm putting the screws in. Now I'll just do up the 2 screws. Okay, now we're going to push the main part of the capillary into the oven. And again, make sure this stays away from the electrics because it is steel. So I'm just going to softly turn that up so it's well away from the electrics. Now we'll slide this back on. All the way to the end. Now I'm just going to push the capillary back and carefully putting a rounded bend. Do not kink the pipe. And there we go. Put the 2 screws back in. And there we go, ready to reassemble the cooker and test. Okay, there we go. The little light's just gone out on the cooker. That means it's already got to about 70 degrees. By turning it up, you can see the light that's coming on. That means electricity is now going to the element, and when it gets to temperature, it goes out. That's all working perfectly. Now let me show you quickly before the end of the video how a thermostat works in detail. Okay, as promised, I said I'd show you how a thermostat works, and I'll also take one apart to show you the inner workings on the thermostat. Firstly, in the off position, I've got the multimeter connected into continuity. If it is working correctly, we have a feed in and a feed out on this thermostat. Some thermostats come with multi-connections, but basically when we turn the thermostat from the off position to say 100 degrees, this is now allowing electricity to flow through. Now as the probe gets to temperature, because it's filled with gas, it will disconnect. Okay, the easiest way for me to show you a thermostat working is we'll set it onto a temperature, and as you can see we've got continuity. I'll now light my blowtorch to simulate the heat on the oven, and in a second this will go open circuit. There we go, open circuit. I'll put it in the water now, and this is the oven cooling, and now we've got a circuit again. Now this is sending electricity to the element, and you're able to increase the temperature, and once it's got to temperature it disconnects and then energizes the element until the point where it gets to the correct temperature, and it will disconnect. There we go, disconnected again. Now the oven starts to cool, and now allows electricity to flow back through to the element. That's basically as it should be. You can actually do some tests with your own thermostat in a controlled temperature, so you might need to borrow someone else's oven to check your thermostat, set it to 100 degrees, put this inside. It should be within 10-20 degrees either side of what the oven temperature that's working is, and that way you can test your thermostat. Now it's very important when fitting thermostats you do not damage or bend or kink this capillary tube. It is full of gas. I have sold these in the past to customers who said it's too long and they've cut it and then said it's not working. But basically you should never damage this tube in any way. Make sure you don't put any 90-degree angles on it. Try to give it a reasonable curve, because remember, inside here and all the way through to the tube until the inside of the thermostat is all gas, and the gas basically expands and contracts towards the temperature of the oven. Okay, now we're going to have a detailed look, so I'll zoom in on this and take it apart for you so you can actually see the expansion chamber and you can see the points on the actual thermostat. On some thermostats there are adjustment screws, especially on the early ones like Diamond H, but as they get more modern they don't have the adjustment screws. They're preset, which is a shame because you used to be able to adjust them. In here you can see a set of points, and these points are what are controlled by this expansion chamber here. When we rotate this arm, there is an adjustment which will adjust the height of the expansion chamber, therefore increasing the range on the cooker. So it might be a very close contact on 50 degrees, 60 degrees, but when you turn it up to 200 degrees, therefore the gas must expand further. Yeah, you can just see in there. So the gas will have to expand further, meaning more energy has to be created, in other words heat, and then it will open and shut these points which you can see inside here. And that's basically how a thermostat works. Thank you very much for watching this video. I apologise it was so long, but there are so many different variations of cooker, I needed to show this for everybody. Please remember to support the website by buying your parts from us, and if you did find this video very helpful, please remember we have a donate button on the links above or in the description where you're able to contribute to the website. Thanks very much indeed for watching.